In this problem, I receive an array of integers r, and I need to return true or false depending on whether or not the number of occurrences of each value in r is unique. Let's take a quick look at an example. Suppose r equals 1, 2, 2, 1, 1, 3. The distinct elements are 1, 2, and 3. When I count how many times each element appears, I notice that 1 appears 3 times, 2 appears twice, and 3 appears only once. So no two values have the same number of occurrences, which means I return true. To solve this problem efficiently, I decided to use a two-step algorithm. At the beginning, I will count how many times each number appears in the initial array. I will keep these counters in CountMap. I will then check if the number of these occurrences is unique for each value. First, I will count how many times each number appears in the initial array. Let's start by understanding what an unordered map is. Unordered map is an associative container from the C++ STL library that stores components characterized by key and value. A key is a part of the element that establishes the order in which the element is stored in the container, and a value is a part of the element that represents the value assigned by the element with the paired key. The key of an element is unique. In a data collection, there cannot be more than one element with the same key. If an attempt is made to insert an element with an already existing key, the value associated with that key will be overwritten. We use unordered map because the order of the elements is not important here and we want quick access to the elements through the keys. If we needed an ordered collection, we could use map. Elements in an unordered map aren't stored in a specific order. The order in which the elements are accessed can vary and doesn't follow the order of insertion. Using this library is very efficient for situations where we need to search or insert elements quickly based on a key. It is ideal for implementing data structures such as dictionaries, symbol tables, and others that require fast lookups, being a very powerful and efficient container for managing key-value pairs in C++, providing excellent performance for most common operations due to its hash table-based implementation. In the case of the current problem, CountMap has keys of type int and values of type int. The for loop is a range-based for loop that iterates through each num element in the R array. This type of loop simplifies iterating through the elements of a collection, such as arrays, lists, matrices, and many on, because it provides a more concise and readable syntax compared to the traditional for loop. For each element with the key num in R, the value associated with the key num in CountMap is incremented. If num doesn't already exist in CountMap, a new entry will be created with an initial value of 0, which will then be incremented to 1. As an example, let's consider that r equals -3, 0, 1, -3, 1, 1, 1, -3, 10, 0. First, I traverse the array. In CountMap, I count how many times each element appears when I traverse R. So I first take -3 and say in CountMap that it appeared once, so far. The next element in R is 0, and I count that in CountMap, so I say -3 appears once and 0 appears once. Then the next element is 1, I count that too. So far, I know that -3, 0, and 1 all appear only once. Afterward, I encounter another -3, so in CountMap, the number of appearances of -3 goes up by 1. Then I encounter another 1, and another 1 on the next position, and another 1 on the position after that. So after performing the algorithm for each one, CountMap ends up with 4. So for the first one encountered, count map is at 2. Then for the next one, it becomes 3, and finally it becomes 4. Next, I find the 10. I now say in count map that -3 appeared 3 times, 0 appeared once, 1 appeared 4 times, and 10 appeared once. And on the final position, I find another 0. So my final answer is that -3 appeared 3 times, 0 appeared twice, 1 appeared 4 times, and 10 appeared once. So now that I determined count map, I can move on to the next step. I now need to check if the occurrences are unique. To do that, I use an unordered set to check if the number of occurrences of each element in R is unique. Why do I need this data structure? An unordered set allows me to store distinct values and efficiently check if a value has already been added to the set. In the case of this problem, I want to check if the number of occurrences of each element in R is unique. If I encounter the same number of occurrences twice, it means that the occurrence numbers aren't unique, and I'll return the answer false. The search operation I need in unordered set has O of 1 time complexity, which makes the verification fast. Compared to other data structures, for example a matrix or a list, unordered set provides a more efficient verification for the presence of a value in the set being searched. Using the for loop, I go through all the pairs key value in count map. Since count map is an unordered map that stores each element in the array and its occurrence count, I'll use auto entry, which is a reference to each key value pair in count map. Then, using the statement if uniqueset.find of entry.second isn't equal to uniqueset.end, I check if this number of occurrences entry.second already exists in uniqueset. Entry.first is the number in the array, and entry.second is the number of occurrences of an element in the count map. I search for entry.second in uniqueset using uniqueset.find of entry.second. If entry.second is found in uniqueset, meaning if the expression uniqueset.find of entry.second isn't equal to uniqueset.end is true, it means that this number of occurrences is not unique, and so I returned false. If the above expression isn't true, so I don't need to return false, it means that I have uniqueness, and using uniqueset.insert of entry.second, I insert entry second into uniqueset. This way, I make sure that the following iterations will check the uniqueness of the number of occurrences with all the numbers of occurrences encountered previously. Finally, I return true. If we didn't return false at all, it means that the final answer is true, meaning there are no duplicates in the number of occurrences. In conclusion, to solve this problem, I used an efficient approach based on two C++ data structures, unordered map and unordered set. Unordered map allowed me to quickly and efficiently count the occurrences of each element in the array. Unordered set helped me check that these occurrence numbers are unique, making sure there are no duplicates. By traversing the array to build a map of occurrences and then checking for their uniqueness in a set, my algorithm works in linear time with respect to the size of the array, thus providing an optimal and clear solution. This algorithm can be used to solve similar problems involving counting and checking the uniqueness of elements in a collection, demonstrating the utility and power of these data structures in the C++ STL library. Now, let's put this algorithm to the test and ensure it meets the problem's requirements. Keep in mind that you are welcome to optimize this code or explore alternative solutions that might prove more efficient than the one presented.